All right, guys, let's talk about finding volumes specifically of prisms today. Prisms are actually really nice shapes. And just to make sure, we'll go over real quick what it means to be a prism. And so the conventional formula for finding the volume of any prism is this highlighted here in the yellow. It is the volume of any prism equals big B times H. And B, a lot of people think of B as standing for the base, but I guess it is. It's of the base shape. It's the area, though, right? So we actually need to calculate the area of the base shape of the prism. So we'll talk about what that means too. And then the height is just basically the length of that prism. I guess it could be the height if it was standing up on its base shape, or it could be laying down, at a different orientation. So length, height, kind of the same thing. Just make sure you know the differences. And let's take a look, actually, what a prism is. So I like to describe a prism as, I like to think of it as being like I like to say a slinky, okay? And not a circular slinky, but because that actually wouldn't be a prism. That would be more of a cylinder. But think of like a tube, right? Let's think of maybe like a triangle. So let's start with a triangle, okay? And I always like to say, so if you can come up with a two-dimensional shape made up of nice straight lines, okay, we call that a polyhedron. So a nice straight lined closed shape. It could be any shape. We'll start with a triangle just to make it nice. And basically take that shape and slinky it. So stretch it out, turn it into a tube. So maybe you got like a triangle, tubing or pipe or something like that. Um, Here's what this might look like. So that shape right there is a prism because the base shape, so the base shape is always the shape that the slinky is being slinkied from, if that makes sense. Okay, and they're always the same on each side. So these two triangles, even though I probably didn't draw this perfectly um, symmetrical, these two triangles on each side should be the same shape, the same orientation and everything, okay? So these two shapes right here, this shape, the triangle, they're both the same triangles. Okay, the triangle is the base shape. Okay, so this tube, this prism, is being stretched out from the original triangle, right? And it's the same on each side. So basically, what you can think of with a prism is this triangle is just being repeated. I'm still not drawing these perfectly. I'm just kind of freehanding this, right? But so these triangles are being repeated over and over and over. That's a little bit skewed, but I think you get the point, right? This triangle is just being replicated, right? It's like a stack of papers setting on top of each other, right? It's the same paper just stacked on top of each other. Well, the same thing here. It's the same triangle. You could think of it as just being stretched out into a tube. So let's look at another one here. So we could do we could do like a trapezoid. Maybe I always like to think of it as like a bar of gold or something, you know, trapezoid or a little ramp or something like that. If we take that trapezoid and stretch it out, right, into a tube, so basically we're just taking that same trapezoid and replicating it over and over and over and over again. So we get, that's not perfect, but you get the idea, right? So that's a prism because the base shape, right, which is the shape that the prism, the tube, the slinky is being created from. So highlight that, right? So that shape right there, that's the base shape. That trapezoid is the base shape. And here's the length. This dimension right here is the length or the height. Okay, it's a distance that tube or slinky is being stretched. Same thing, let's go back up here, right? This triangular prism is I'll highlight it here. This dimension here is the length or the height, right? It's the distance that the slinky or the prism or the tube is being stretched. It's the distance that that triangle is being replicated. Same thing. Okay, so I think you get the point, hopefully, right? So let's actually run a couple of numbers here. Let's just do one. Let's do an example. Let's find an actual volume, and we could do I don't know. We'll just call it. Let's call it a tent. Let's get an isosceles triangle going here. Okay, let's do something like this. We'll say this is some type of a tent. Okay, and let's give some actual dimensions to this tent. I don't know. We'll just make it up. Let's say it's 6 feet wide. by, and then let's give it a perpendicular height, right? A perpendicular height, let's say of, I'm just making this up, let's say of 8 feet. Okay, now let's say that this tent, when it gets set up and everything, okay, let's actually, so here's our base shape right here, and then we're going to slinky this out, right? Let's give this tent some length or height or whatever you want to call it, okay? This would be more like a length since it's sitting on the ground. And there's our tent, all right? And let's say our tent is, I don't know, let's say 10 feet long. 10 feet long, okay? Now, let's say that we maybe needed to size an air conditioner or, a fan or something for this tent. And the sizes of these appliances are based on volume, right? And so let's say that we needed to calculate the volume of our tent. So let's break this apart, okay? So this is a prism. So it's going to follow the formula V equals B, right? Which means area of the base shape times the height or the length. Okay, I'm going to scoot this down here. Actually, I think I'll just come over here to the side so we can see it. All right, so let's go identify our base shape. So our base shape is always the shape that the prism or the tube or the slinky has been slinkied from or stretched from, right? So this shape right here, that's our base shape. All right, I'll hatch that maybe with some highlighter here. Okay, so this shape right here is our base shape. We need to find the area of that shape. So big B, right, is going to equal the area of a triangle. Okay, so we got to be careful. The area of a triangle is the triangle's base times its perpendicular height divided by 2. So I always like to use the formula BH over 2. Okay, so base times its perpendicular height divided by 2. That's the same thing as saying 1/2 times base times height. Those are the same formulas. I like to use this one, okay? So let's go ahead and run that. So big B, area of the base shape, is going to be 6 times 8 divided by 2, right? And 6 times 8 is going to give us 48 divided by 2. So therefore, big B is going to equal 24, and those are feet squared. All right, so we got big B, we got the area of the base shape. I'm going to scoot this down just a little bit here. Now we can put these pieces together, right? So we found big B. Now we already have H, right? It's the length or the height of the prism. In this case, I might call it the length, right? It's set on the ground. So we got H. All right, let's just go ahead and put them together. So the volume is going to be big B, so 24, and those are feet squared, times 10, and that's feet, right? So we're going to get 24 times our 10, which is going to give us, so we got feet squared here times feet. That's going to give us feet to the third power. That's where we get our feet cubed at, right? So this answer is going to be 240, and these are going to be feet to the third power. Volume is always cubic feet. And there we go. So there's how we find the volume of specifically a triangular prism using V equals big B times H formula. So there you go. Hope this helps.